students, welcome to the E-class of mathematics. Today we are going to start exercise B of chapter number 7, that is fractions. So the topics which we are going to study in this video class, they are as follows. First topic is equivalent fractions. Second, comparing fractions. Third, ascending and descending order of the fractions. And the last one is fractions in lowest term. So in this video class we'll be learning about what all these fractions or what all these terms represent and how we can solve the questions related to all these terms. Now the first topic, that is equivalent fractions. First of all, we'll study what is an equivalent fraction. So the fractions that represent the same portion of the whole are called equivalent fractions. That means you are given a fraction and the same fraction is given as another fraction, but it is the multiple of that given fraction. We'll study with the help of an example. If we multiply or divide the numerator and the denominator of a fraction by the same number other than 0, we get an equivalent fraction. That means I told you are given a fraction, and if you take out the multiples of that given fraction, then you will get an equivalent fraction. You divide with the same number or you multiply with the same number in the numerator as well as the denominator, you will get the equivalent fraction of the given fraction. Now let us study this equivalent fractions with the help of an example. Use multiplication to write two equivalent fractions of 2 upon 5. So what we'll do, we'll divide 2 upon 5 in the numerator as well as the denominator by 2. We'll get the answer as 4 upon 10. So the one equivalent fraction of 2 upon 5 is 4 upon 10. When you will reduce this 4 upon 10, you will definitely get 2 upon 5 only. Now another equivalent fraction, 2 upon 5, when multiplied by 3 in the numerator as well as in the denominator, we'll get the answer as 6 upon 15. So 6 upon 15 is another equivalent fraction of the fraction 2 upon 5. Similarly, you can multiply in the numerator by 4 and denominator in the 4. You will get as 8 upon 20. So in this manner, you can take out infinitely equivalent fractions of the given fractions. But the only condition is you need to multiply with the same number in the numerator as well as in the denominator. Second question is, are the fractions 5 upon 6, 15 upon 12 equivalent? We are supposed to tell here that the given two fractions are equivalent or not. So the best method, just cross multiply the fractions and find out. So 5 upon 6 and 15 upon 12, when we'll cross multiply these fractions, we'll get 12 5s are 60 and 15 6s are 90. So here you can see when 12 is being multiplied by 5, we are getting as 60, and when 15 is being multiplied by 6, we are getting 19. So 60 is not equal to 90, therefore the products are unequal. So the fractions are not equivalent. This is first method to find out whether the given fractions are equivalent or not. The second method is you need to take out the LCM of the given fractions, LCM of the denominators of the given fractions. Then you need to make the denominators of both the fractions same, and then you have to find out whether the given fractions are equivalent or not. Now the term comparing fractions. By the term itself, comparison, we understood that we have to tell whether the given fraction is greater or smaller. Among all like fractions, the one with the greatest numerator is the greatest. The first point which we need to keep in mind while doing the comparison between the fractions is that among all the like fractions, the fraction with the greatest numerator is the greatest fraction. Then, among fractions whose numerators are equal, the one with the smallest denominator is the greatest. Earlier we were talking about the one with the greatest numerator will be the greatest, but here when all the numerators are equal, earlier the numerators were unequal, and second portion the numerators are equal, with the help of the denominators you need to find out whether the given fraction is greater or not. So if the denominator is smaller, the fraction is the greater fraction. Then to compare other kinds of fractions, we can convert them into like fractions first and then compare their numerators. So first of all, another method is if both the numerator as well as denominators are different, then we need to convert the given fractions into like fractions first by taking out the LCM of the denominators of the given fractions, and then we have to compare their numerators. This is the method which is to be applied when the denominator as well as the numerators they are different. Another method, you just simply cross multiply and compare their products. So we can use all these given points in order to find out whether a given fraction is a greater one or a smaller one. Now let us see with the help of some of the questions. Compare 4 upon 15 and 6 upon 17. So we need to cross multiply these fractions. 4 multiplied 17 is equal to 68 and 6 multiplied 15 is equal to 90. As you can see here, the products are unequal and 68 is less than 90. So 4 upon 15 is less than 6 upon 17. We took out the answer that which fraction is greater and which fraction is smaller. This was the first method. The second method is convert the fractions into like fractions and then compare the numerators and then find out the answer. Now the next topic is ascending and descending order. We all know the meaning of ascending and descending order. Ascending means from smaller to the bigger part, and then descending means from bigger to smaller. But here we are talking about the ascending and descending order of the fractions, not about the numbers. So we are talking about ascending and descending order of the fractions. So there are some points or there are some rules which are needed to be followed while finding out the ascending and descending order of the fractions. The first rule is for equal bottom fractions, greater top means greater fraction. That means if the numerator of the given fractions are unequal and if the denominators they all are equal, then the numerator, which is the greater one, is the greatest fraction. Second rule, for equal top fractions, greater bottom means smaller fraction. That means if all the numerators are same and the denominators are different, so greater will be the denominator, which means smaller is the fraction. Just the opposite, when we'll have the equal denominators, greater will be the numerator, greater will be the fraction. But when we'll have equal numerators, greater will be the denominator, smaller will be the fraction. These 2 points you need to keep in mind while solving the questions related to the ascending and descending order of the fractions. Let us see with the help of a question. Write in descending order 2 upon 9, 8 upon 9, 6 upon 9, 7 upon 9, 1, 4 upon 9. So first of all, we will convert this mixed fraction into improper fraction. So this 1, 4 upon 9 comes out to be 13 upon 9. Now we'll see all the denominators are same. So when the denominators are same, we need to compare the numerator. If the numerator is bigger, the fraction is bigger. So here the biggest numerator is of 13. That means 1 4 upon 9 is the biggest fraction. Then 8 upon 9, then 7 upon 9, then 6 upon 9, and then 2 upon 9. So the fraction with the greatest numerator will be the greater fraction. I am repeating again, the fraction, the greatest numerator will be the greatest fraction here, and then we can easily find out the descending order of the fractions. Next question, write in ascending order 14 upon 21, 17 upon 21, 12 upon 21, 22 upon 21 and 1 2 upon 21. So first of all we'll convert this mixed fraction into improper fraction. 1 2 upon 21 turns out to be 23 upon 21. Now all the denominators are same. With the help of the numerator we'll find out which is the smaller fraction. So here the smallest numerator is of 12 upon 21. So 12 upon 21 is the least fraction. Then 14 upon 21, then 17 upon 21, 22 upon 21 and then 23 upon 21. That is 1 2 upon 21. Now the next topic is fractions in lowest term. A fraction is said to be in its lowest term if the only common factor between its numerator and denominator is 1. That means the only common factor between the numerator and denominator is 1. It cannot be reduced further. Let us see with the help of an example. Reduce 18 upon 54 to the lowest term. So first of all we'll see which is the common factor between 18 and 24. You can easily see the common factor between 18 and 24 is 2 here. So 2 9s are 18 and 2 27s are 54. Then the common factor between 9 and 27 is 3. So 3 3s are 9 and 3 9s are 27. Now again the common factor between 3 and 9 is 3. 3 1s are 3 and 3 3s are 9. Now 1 upon 3. There is no common factor other than 1 in this fraction. So this is the lowest term of the fraction 18 upon 54. 1 upon 3 is the lowest term of the fraction 18 upon 54. Let us move towards the home assignment. The very first question, fill in the blanks. 3 upon 4 equals to, in the numerator you need to fill, denominator is given 24. That means you have to take out the equivalent fraction. Then second, 8 upon 9 which is equal to, numerator is mentioned as 40. You need to find out the denominator. Again, you need to find out the equivalent fraction. Question number 2, which of these are in the lowest terms? 3 upon 11, 5 upon 20, 25 upon 36. So here you need to find out the common factor between all the numerator and denominator of these fractions must be 1. If the common factor is 1. That particular fraction is in lowest term. Next, fill in with less than, greater than or equal to. First question, 7 upon 9 and 6 upon 9. Which one is greater, equal to or less than? You need to find out. Then 12 upon 17 and 12 upon 13. So now I hope you must have understood this exercise very well. You need to practice all the questions of this exercise. Thank you very much for watching this video. Have a great day ahead.